Forests to fuel, unlocking green hydrogen from wood waste. Hydrogen is a simple molecule, but it plays a big role in our lives. This molecule also shapes the nature around us, water, plants, and life itself. Today, hydrogen can power our world. In fuel cells, it combines with oxygen to make clean electricity, and the only output is water. It can also move our cars, giving us clean fuel with fast refueling times. Hydrogen trucks are already on the road. And even trains are running on hydrogen, connecting mobility with clean energy. In steelmaking, hydrogen can replace carbon to cut emissions. In food, it helps process oils and fats safely. And in the chemical industry, it is key for producing ammonia and refining fuels. Let's look at how hydrogen is produced: gray, blue, and green. Gray hydrogen comes from fossil fuels, steam methane reforming, coal gasification, and oil oxidation. But gray hydrogen releases a lot of carbon dioxide. Blue hydrogen is gray hydrogen, but with carbon capture and storage. It is cleaner, but still depends on fossil fuels. Green hydrogen comes from renewable sources. It can be made by electrolysis, using clean electricity, or from biomass through gasification and fermentation. But green hydrogen is expensive today. Costs are high, and scaling up is still a challenge. That's why more than 95% of today's hydrogen is gray, with a heavy carbon footprint. Industry and decision makers often focus on cost, not climate, making green hydrogen less attractive right now. So the big question is, how can we make green hydrogen production economically viable? One answer may come from biomass. Canada has vast forests, and forestry residues represent a big opportunity. Every year, residues from sustainable forestry amount to nearly 40 million oven-dry tons across Canada, including 9 million oven-dry tons in Quebec. This is a massive stream of unused biomass that could become high-value products. Today, many companies use pyrolysis to turn biomass into biogas, bio-oil, and biochar. But biochar has problems. It can be unstable, highly reactive, and costly to store and transport safely. This limits its applications. In some cases, biochar has even caused fires during storage and transport, making it unsuitable for long-term or high-value use. This is where our innovation comes in. At the Energy Innovation Lab at Université Laval, we turn these forestry residues into high-value products. Our process converts unstable biochar into clean biohydrogen, leaving behind stable, high-quality biochar, solving both biochar instability and hydrogen cost at once. Quebec industries can then use biohydrogen for energy and ammonia production, while stable biochar provides clean carbon for aluminum and steelmaking. This also supports regions with biomass but no electricity. On the technical side, we started with a challenge. Biochar from pyrolysis is often unstable because it contains too many volatile compounds. Instead of seeing that as a problem, we turned it into an opportunity. By capturing and upgrading those volatile gases, we produce clean biohydrogen. What's left behind is stable biochar, strong, durable, and ready for long-term applications. So from one process, we get two valuable products. This also makes economic sense. Our approach creates two revenue streams: selling renewable hydrogen and selling stable biochar. By producing hydrogen from forestry residues, we lower the cost compared to traditional green hydrogen. And for pyrolysis companies, there's a bonus. They can even use that hydrogen to generate their own electricity, cutting operating costs and turning low-value biochar into a real source of profit. And of course, we never lose sight of the bigger picture, the environment. With this innovation, we cut greenhouse gas emissions by replacing fossil hydrogen. We lock carbon away for centuries in stable biochar. And by putting forestry residues to good use, we support sustainable forestry while making sure nothing goes to waste. With this innovation, we can move Quebec and Canada toward net zero while keeping our planet clean for future generations.